sometimes our functions are a little bit more in depth, I guess, and they're not representative of the parent functions that we are used to with 1 over x and 1 over x squared. So our rational functions can come in different forms that we're not used to seeing. So it's important that we know how to find our vertical asymptote. Our vertical asymptote, that procedure, first we're going to factor the numerator and the denominator. So factor the numerator and the denominator. And then your second step is you're going to cancel out common factors. That says common. Factors remaining, you're going to set those equal to 0. So the remaining factors get set equal to 0 in the denominator. So those remaining factors in the denominator get set equal to 0. And then those are your vertical asymptotes. Those are your points of discontinuity, which are your vertical asymptotes. Now, it's a special kind of point of discontinuity, and we call it a vertical asymptote. The common factors that cancel out, those are points of discontinuity too, but those are the canceled out values, are your wholes, and we've already worked with those. So let's work with these. We've got f of x equals x plus 2 over x squared minus 2x. Let's first factor. So I'm going to have f of x equals x plus 2. Look, I'm just finding vertical asymptotes. So we're not doing any calculus here. X plus 2 over x times the quantity, x minus 2. Well, I don't have any common factors that cancel out. So I'm going to take the remaining factors in the denominator. The remaining factors are x and x minus 2. And I'm going to set each one of those equal to 0. X equals 0 and x minus 2 equals 0. I'm going to solve, and those are my points of discontinuity that result in vertical asymptotes. So our vertical asymptotes are x equals 0 and x equals 2. Those are the vertical asymptotes. Fantastic. Okay, let's try another. X squared plus 2x minus 8 over x squared minus 4. First step is I'm going to factor, so x plus 4, x minus 2 over x plus 2, x minus 2. And that's what f of x is equal to. There's no calculus involved. This is a 4. In case you can't read that, that's a 4. My handwriting was pretty yucky there. Pretty awful. Okay, the x minus 2's cancel, leaving x plus 2 in the denominator. So we're going to take that x plus 2 and set it equal to 0. And our vertical asymptote is at x equals negative 2. That's a vertical asymptote. Now, why is it important to be able to locate the vertical asymptote? Because look at our functions that we're going to be dealing with. We need to be able to identify our limits at those points of discontinuity that result in asymptotes. So we've got x squared minus 3x over x minus 1. X squared minus 3x over x minus 1. We want to find the limit as of that function as x approaches 1 from the left. So we're going to have x times x minus 3 over x minus 1, and I'm finding the limit as x approaches 1 from the left of that function. Well, that's a vertical asymptote at x equals 1. So really I just need to find out what's happening. I know that my graph is going to hug that vertical asymptote and either approach positive infinity or it's going to approach negative infinity. So it's going to rise infinitely or fall infinitely. How do we find out what's going to happen? Well, 1 to the left would be maybe 0.9-ish. So 1 from the left would be a 0.9-ish. So I'm going to have, let's try 0.9. So we're going to have 0.9, that's a positive. 0.9 minus 3, that's a positive, right? Nope, that's a negative. Over 0.9 minus 1, that's a negative. So look at what I'm going to write here. Positive for 0.9. 0.9 is positive. 0.9 minus 3 is negative. And then that's over 0.9 minus 1 is negative. So we have a negative over a negative is a positive. So this results in positive, and that's how we know that we're going up towards positive infinity and not down towards negative infinity. So let me make a note. Once we know the vertical asymptote, then the infinite limit as we approach the vertical asymptote from the left or the right will be either positive infinity or negative infinity. So let's try this same function, x squared minus 3x over x minus 1, this time looking at 1 from the right. So when we look at 1 from the right, we're going to be talking about 1.1 perhaps. The limit as x approaches 1 from the right of x, I'm going to factor this because I really liked factoring. Then I didn't have to worry about squaring numbers or anything like that. So let's try 1.1. So when we put a 1.1 in, we're going to have 1.1, which is a positive, times 1.1 minus 3, which is a negative, over let's use this green, 1.1 minus 1, which is a positive. So we'll have a positive in the denominator. We'll have a negative in the numerator. And we'll also have a positive in the numerator. Well, that is going to result in a negative. Therefore, we know that as we get closer and closer to that vertical asymptote, the curve is falling to negative infinity. Okay, you try the next one. The limit as x approaches 2 from the left, and the limit as x approaches 2 from the right of the same function. Go ahead and press pause, and when you come back, we'll press play and see if you've got it. You should have had, sorry, I didn't mean to laugh. You should have had the one on this first try, you should have had positive infinity, and the one on the right, you should have had negative infinity. So if your work looks similar to the work I've shown, you are definitely on the right track. What we'll talk about in the next video, and we'll probably do this next video in one big video, we're going to talk about limits at infinity, which are called your horizontal asymptotes.